Alright, folks, I'm going to walk you through the confidence interval for a difference in means. The idea is that you're using many of the same things that you did for the hypothesis test in a slightly different way. So the formula is you're estimating the difference in means of the population by your sample difference of means. You're adding and subtracting a critical value. That one can be interesting. I'll figure out what to do with that one. And the same standard error as we had before. So you need two random samples, populations are normal, or both sample sizes are bigger than 3, or check the shape. And 10% condition, I also want to mention 10% condition is about independence, which means that the two samples need to really be not related in any way. So that question 35 on the classwork about the literacy rates, those two groups of numbers were not independent of each other at all. They're connected. So that's not a good time for a two-sample T procedure. So we have here two students who went and got 10 packs of cookies from 10 stores. Opened each bag, grabbed a random cookie, and counted how many chocolate chips there were in the Chips Ahoy bags, and the great value, like I'm going to assume those are the generic brand ones. Right? So they're looking at which one has more chocolate chips. Okay. So for the confidence interval, I ended up putting these two guys in my list, this one in list 1, this one in list 2. I need that for the shape check. I also need to get any of the means and deviations for this sample. But before I do that, I'm going to start with the parameter naming. Okay, so we are estimating the mean number of Chips Ahoy chocolate chips minus the mean of great value chocolate chips. So it's the true difference of the means. So true difference in mean number of chocolate chips. And Chips Ahoy cookies. And great value cookies. So that's it for the parameter for the state step for confidence intervals. So next up, we're doing the check. So we are doing a two-sample T interval or a difference of means interval. So are these random samples? I think the students did a really good job. So we're going to say random samples, plural, both given. For large counts, we have options. Population is normal, unknown. Sample size greater than 30, no. So we're going to have to do a shape check for this one. So I put these guys in my calculator. I'm going to go and stat plot both of these. I'm going to turn both of them on, actually. So I have one plot on. I'm going to turn on plot 2 as well. List 2 is going to go here. If I go back to plot 1, I think I'm graphing the wrong thing. So I'm going to put list 1 graph first and list 2 graph second. I'm going to zoom stat. Try to zoom stat. Okay, so these are my two. Both of these are symmetrical and rounded. I do have to provide that evidence. So I'm going to trace. When you're doing this and you have two of these on at the same time, you're going to trace the first one left and right, and then if you want to move to the second graph, you should go down. So I do need the numbers on the bottom. So this is going from 14 to 26. Which means the middle number is going to be 21. No. Okay, those two numbers are...